Hey math friends, today we're going to look at the 6-5 Day 2 notes. If you haven't already, I need you to pause the video and please complete the warm-up questions 1 through 8. Welcome back! So for the warm-up today, you were asked to start off by plotting 3 different points. Please check your answers and let me know if you have any questions. Remember that a negative r value means you go to the angle on the opposite side of 5 pi over 3, which in this case would be 2 pi over 3, and then you would go out that distance of 2 units. For question 2, you were asked to name 3 other points that represent the same point as 2, 30. Remember to keep the same r value. You need to find what's coterminal to what was given, and that's where I got that 2, negative 330. And then remember that to get that the other 2 points, we need to change the r value. Well, if you want to change the r value, we need to go to the opposite side of the given angle. So in that case, that means we need to add 180 to the original answer. Technically, you could subtract 180 as well. But remember, once you find that opposite r value, your other and final ordered pair should be coterminal with the one you just found. So remember to be coterminal. That's again adding or subtracting 360. The nice thing is if you look at all 4 of these ordered pairs, the given and the 3 you just found, they'll all take you to the spot that I've labeled number 2. Finally, you were asked to complete questions 3 through 8. In questions 3 through 8, you were asked about symmetry. Remember that theta equals 0 is representing the x-axis. Theta equals pi over 2 is representing the y-axis. And remember, the pole is when we rotate 180 degrees and you get the same exact graph. So check those answers. Let me know if you have any questions. You obviously can see I used highlighters to show how that symmetry worked for each of these problems. Now, the final thing I wanted to discuss in this video was how to graph using Desmos. So we're going to skip the second page for now. This goes how to do graphing with your calculator. But what I would like for you guys to do is go to the last, or I guess the second to last page, page 3. And I want to talk about how we're going to use Desmos to graph. Now, your homework for tonight is going to be to complete these last 2 pages and submit this entire completed note sheet to me through Schoology. So in order to complete these last 2 pages, you need to know how to graph polar equations using Desmos. If you haven't already, please do a split screen with the Desmos app. And what I would like for you guys to do is after you have set this up with a split screen, I need you to go to this little wrench up here, the gear. Or I guess that's a wrench, right? I don't know tools. I know it's not a hammer, but you need to go there. And if you notice, there's this grid option, and you need to change it to the grid that is a polar grid. Also, make sure you're in radians, just to be consistent with what I have. Now, if you go to where it says box 1, and if you want to type in this first equation, I want you to note that for the first 6 graphs you're doing, these are all circles. If you want, instead of typing each of these in separately, what you could do is say R, and then go to the equal sign. And then instead of typing in the 4, then the 2, then the negative 6, you can actually go to the ABC button and type in A as a slider, and then go back to the 1, 2, 3, go to functions, and then hit the cosine here, and then we can put a theta. Now, to do the theta, you have to go to the ABC button again, and above the little X, you see that X that, I don't know, is like gray, there's a theta button there. Now, after you do this, you can add a slider for A, and the slider allows you to change that A value in the front and kind of see what happens for different values of A. The whole point of this activity is to understand how different values are going to change the given equation. So notice that if you have a number in front of the cosine theta, that number is going to tell you about your graph. And specifically, if you notice, and we can even zoom into the graph, that number right there is giving us the diameter of the graph. So that's something you're going to be doing. You're going to be kind of answering these questions on the side, but the answers to the questions on the side are going to help you to have a better understanding of each of these graphs. So what I would like for you to do is after you complete this, so you'll see that to do this first one, we could do this together. I'd count up 4 units. And then again, it doesn't have to be perfect, but you can kind of see that this would create this circle. And we'll just do our best to make it look like a circle. Obviously, if you're not happy with how it came out, you can fix the top here. And the whole idea is just getting the graph. It doesn't have to be perfect, but just kind of seeing that that does in fact represent a circle. And then you can continue on with these next two. And then when you go to the next row, notice now we're changing the cosine to a sine. So you can go back up here and you can delete this. And then you can go back to the 1, 2, 3 functions and then change that to a sine in front. And you will notice then what happens with your graph. You can obviously change the slider, but just check to see how changing this value, positive values for A versus negative values for A, and how they are in fact changing what we're seeing in the graph. Notice again, this value in front is representing the diameter of the circle. But notice now with sine, we're going to see the graph gets cut by the y-axis instead of the x. And it makes sense because when you think of sine, you think of the y values. So think about how with the cosine, it represents the x values, and it makes sense it would be cut by the x-axis. So what I want you guys to do is finish all 6 of these and then write the observations to the side. If you're struggling, there is a key posted, but try to do your best to answer those questions without looking at the key. You're then going to do the same thing for our rose curves. Now, when you're graphing these, notice that you need a number in front, but you also need a number with a theta. So if you want, you can keep it as the A in front, and what you can do is you can insert another slider, and you can put a B here and add a slider for B. And then if we want, we can change that sine back to a cosine. So we can go to cosine. Get rid of one of those sets of parentheses. Now you can change both A and B. So notice for this first one, I'm going to change my A value. You can even move the sliders. I thought you could put one slider on top. Yeah, there you go. You can move one on top of the other if you want the order to be consistent with going left to right. So if we want to change the A value to a 4, we can do that. And then, there we go. Did I get it? And then to change the B value to a 3, whoa, what's happening? You know what's really cool is if you hit the play button to the side. Come on, move over. Come on. There we go. You can actually have the slider move left and right, and it'll show you the effects of changing the B value. So notice why this is called a rose. You can also zoom in and kind of see how far out these petal lengths go, okay, which makes sense that we see this 4 in the front, petal length is 4, and then notice that we have the 3 petals here. Now, if you ever change the window so much that it distorts it, like what you're seeing there, you can always hit that home button and it'll like reshape it, and then you can zoom back in and out. The home being, right. I would point to it so you guys can see, but obviously you can't from where I'm at, but it's the little house in the upper right-hand corner. Now, after you finish these, so notice you'll have to do one changing that to a 5 in front, so, moving the slider so it's at a 5, and then changing the B value to a 4. It's kind of cool. You'll see that this is still a rose, but notice it doesn't have 4 petals. It actually has, if you count it, 8. So really look at the relationship between this number in front of the theta being even versus odd and how that affects what we're seeing in our graph. So you can finish those and then answer the questions to the side. And then there's a couple to try. Try to do it without using Desmos and see if you have a good understanding of what these numbers do to your actual graph. Actually, not finally, the third type that you're going to be practicing is this limosone that I had talked to you about. Apparently, there isn't the accent on the top. I guess it goes on the bottom of the C. So good thing I had no clue what I was talking about there. If you want to do this, we can just remove these sliders by clicking the X. And if you even want to just remove that, and then to type in this new equation, you can put the R equals, and then you can say A, and then we can put plus B, And then we can put the cosine. So we can go to our functions. We can put in cosine and then the theta. And then we can add a slider for all. And then again, you can play around with these numbers with the a value being 1 and the b value being 2. You can see what that's doing with your graph. And then you can copy that graph down. Obviously, you can change and then note what happens when you change the a to 2. Come on. And then the b to 2, what we're seeing here. Oh my gosh. It's because I want it to be 2. That's why it's not going to. Oh, come on. Seriously? There we go. I'm sure there's an easier way. I actually think you can change your scaling here. Yeah, you can have your step go up by 1, increments of 1. So if you do that, then you can, oh, it looks like I could even just change. Oh, wait. Okay, now I'm just showing you things that you shouldn't be doing. So let's add that slider for A. Let's get rid of what I just did. But I'm pretty sure if you click, yeah, in front, you can have the step. I'm almost positive you can change it up so it's a step by 1. Let's just say -10 to 10. And then go back to, oh, okay, that's not what I wanted to do. But then there we go. So then I did all that work so my A can go up to 2 and I still can't do it. And then B, let's see if I have more success with B. Okay, my children are crying. But again, you can copy down that graph and then make some observations. Again, if you struggle with those observations, just look at the key. But the key thing for the limaçons is really looking at the A versus the B value and looking at the ratio of the two and seeing how the ratio can affect the graph that you're seeing in that from each of the graphs that you get from Desmos. Finally, the last graph you're going to look at is the lemniscates. When you're graphing the lemniscates, let's X out of here, X out of here, X out of here. Unfortunately, you're going to see that this says r squared equals, and you can't type in a squared function to Desmos. So what you're going to do is you're going to type in r equals, and then you're going to use the square root button and then type in that 25 cosine. It's cosine, and then we can put the 2 theta. And then from there, you can copy down this lemniscate and then do the same thing with the other 3 graphs here. And then from there, record any observations that you're seeing. Once you're finished with this, please check with the key, just see if there was any observations that you missed, anything that you want to add after reading through the key, and then please submit it to me through Schoology.